It's time to open our eyes to a bright and promising future. We'll rise to the call of the times and create a stronger tomorrow. Let's start to make a difference, teaching everyone to learn through science, health, and technology. We will share our expertise by promoting knowledge and policies. We can build a better world. Let us take a step for ambitious growth, bringing future west for the people. We'll achieve our goals through partnership, creating opportunities by working hand in hand together, accomplish all our dreams for a better quality of life is now within our reach. Let us take a step for a vision so bold, making future plans for the people to grow in a life filled with happiness and faith. Hear us, Savior, living the future is our legacy.
Yeah. It's not ready. Starting. Hello there. A very good day to all participants. Welcome to another session of Mathematical Discourse. My name is Tae Kim Hong, the moderator and the supporting facilitator for this session. On behalf of the Center Director, Dr. Shahjahan bin Asana Kuti, the Deputy Director of the Training Program Division, Dr. Wan Noor Azmin bin Mohammad Sabri, and staff of Xavier Exum, we would like to welcome all of you to this discourse on promoting mathematical reasoning through reason-based learning. What, why, and how? There are two sessions in this discourse. Today, we are going to talk about what and why of reason-based learning. And don't miss our second session on the 6th of May, 2021, the same time, where we are going to talk about the how to apply reasoning in mathematics instructions in a classroom. As the usual practice, we invite audience to raise questions during Q&A sessions, about 5 minutes. Otherwise, you can raise your question in the chat and we'll try to pick up the question to answer you. Here comes the highlight of the day, introducing to all of you the facilitator, Mr. Gan Teng Hock.
Hello.
Mr. Gan, welcome. Mr. Gan is one person who never stopped advocating the importance of reasoning in mathematics since he was a teacher educator 30 years ago. It's a long way. Pandemic can be a blessing in disguise. The challenging situation had triggered us to discuss this topic virtually, to reach out for wider coverage of audience, benefiting more teachers for a more effective teaching and learning of mathematics in a classroom. With this, I would like to hand over the sessions to Mr. Gan. Mr. Gan, the floor is yours now.
Thank you, Ms. Day. Hello, good afternoon, everybody. Allow me to share the screen first. Which one?
At the bottom, somewhere in the middle.
Play. We are very happy to share a discourse on reason-based learning and mathematical reasoning with all of you today. Allow me to first give a brief overview of the discourse. The discourse is divided into two sessions as explained by Ms. Tay just now. Today is the first session and we will be focusing on the what and the why aspect of reason-based learning and also how it is related to reasoning in mathematics. On the second session, scheduled to be on the 6th of May,
Yes.
we will continue the discourse and talking about how to promote mathematical reasoning through reason-based learning. I would like to begin the discourse with a case with these three boys. They are Anthony, Bob, and Charlie. Each of them said something about themselves. However, the unfortunate thing is this boy may not telling us the truth. They may lie to us. But the fortunate thing is we know something about them. These are the things that we know about them. Anthony is a boy who always tells truth. Whatever come out from his mouth must be the truth and nothing but the truth. He will never lie. Bob is sort of a naughty boy. Sometimes he will tell the truth, but sometimes he will tell us lies. We are not sure when he is going to tell the truth or tell the lies. And Charlie is really giving us a lot of trouble because he will never tell the truth. He only tell lies. So our problem now is to find out who is Anthony, who is Bob, and who is Charlie based on what they said and also what we know about them. So can this problem be solved? That is the thing maybe is lingering in a lot of our mind now, right? Just based on this information, can it be solved? The answer is definitely yes. But the question is how to solve it. That we will be relying on the very powerful tools in mathematics. That is reasoning. How reasoning can be used to solve the problem. Now, we will start by making some assumptions about the boy. First, let's assume the first boy is Anthony. So if the first boy is Anthony, and we know that Anthony always tells the truth. So if the first boy is Anthony, then he will say, I am Anthony. But instead, he did not say that. He said, the person at the center is Anthony. Obviously, based on the fact that Anthony always tells the truth, this boy cannot be Anthony. Okay, that's the reasoning we use to rule out the first boy as Anthony. Next, let's assume the second boy is Anthony. And as we know, Anthony only tells the truth. So if the second boy is Anthony, same as the first boy just now, then he will also say, I am Anthony. but instead he said, I am Bob. So looks like we can conclude here that the second boy is also not Anthony. Well, the problem seems to be easier now. With our reasoning, we rule out the first boy. We also rule out the second boy. It looks like we only have the third boy as our choice. So the third boy has to be Anthony.
Wow, I'm impressed.
Interesting, isn't
It
it?
is interesting.
So,
And yeah,
so can you reason out if the third boy is Anthony, who is the second boy? Remember, Anthony always tell the truth.
Charlie.
Charlie, who's saying? Oh,
yeah, the audience, our audience.
Charlie.
okay. Charlie, okay? So it has to be Charlie, isn't it? So if the second boy is Charlie, who is the first boy?
Upper boy is Bob. Bob.
Only one person left, right?
Yes.
Okay, so the first boy has to be Bob. See how reasoning is so powerful just based on one sentence that each of the boy said and also one fact that we know about them. We can reason out who is who for this case. Amazing, right?
Yeah. And is this reasoning, isn't that a deductive reasoning?
Oh,
Mr. Kat?
yes. This is deductive reasoning. Okay, a reasoning where we make specific conclusions based on the assumption that the general statement is true. And logical reasoning will help us to reach a specific conclusion, which is given the name deductive reasoning, a very old but very important and fundamental reasoning in mathematics. Okay, now the case with the three boy may not seems to be directly related to school mathematics. So now we shall look at an example of reasoning, deductive reasoning with school mathematics. And I think this is a case for the primary school. In primary schools, students learn about shapes. They always come across statements like this in the textbook or told by the teacher. A rectangle is a shape that has four sides. In order to understand this statement, reasoning will come into play. Some simpler reasoning that students can use to understand the meaning of rectangle is this. Okay? In order to figure out the answer, they have to reason based on the statement. Okay? So why is this a rectangle? Based on the statement, because it has four sides. Another reasoning they can do is this. This is not a rectangle. Based on the statement, why is this not a rectangle? Because it has more than one side. Okay? Now, reasoning about this statement is not only limited to these simpler questions here. There are, in fact, a lot more deeper reasoning are involved here if we expect the student to learn about rectangle at a deeper level. The first one, this statement, a rectangle is a shape that has four sides. It actually refers to two parts. The first part is a shape is a rectangle. The second part is it has four sides. So if a shape is a rectangle, then it must has four sides. So that is the first important statement. And we will do the following examples of reasoning based on this statement, assuming that this statement is true. Now let's look at these three other statements. So our duty is to decide, is each of these statements true or false? The first statement in reasoning, we call this the converse of the basic statement. The basic statement is, if a shape is a rectangle, then it has four sides. So now we reverse that. If a shape has four sides, then it is a rectangle. Is this true? Well, if we look at this example, this shape has four sides and it is a rectangle. It looks like this is a true statement, right? And many students, especially primary students, will have this thinking. However, we have to be careful about this. Look at this example. This is also a shape that has four sides, but it is not a rectangle. So the second example is a counter example for this statement. It shows that this statement is not true. So what we can conclude about this statement is that this statement is sometimes true, sometimes not true. We cannot be sure about it. It all depends on the example of shape that we have. Now let's look at the second shape, the second statement. It is the inverse of the basic statement, the not. Okay, if a shape is not a rectangle, then it does not have four sides, assuming the basic statement is right. So think about this. A shape is not a rectangle, then it does not have four sides. Again, the example on the left seems to show that this is a true statement. But the example on top that, again, contradict it. It shows that this statement is false. So same with the statement above, we cannot make a conclusive decisions on whether the second statement is true or false. This brings us to the third statement, which is called the contrapositive of the basic statement. If a shape doesn't have four sides, then it is not a rectangle. Because the basic statement says that if a shape is a rectangle, then it must have four sides. Now, if we change it to, if a shape does not have four sides, then it is not a rectangle. Will this statement be always true? We have one example here. This shape does not have four sides, and therefore it is not a rectangle, which is a true statement. And I believe you can find many more other examples of shape which does not have four sides, and they are not a rectangle. A shape with three sides, not a rectangle. Any shape with five sides, not a rectangle. Any shape with number of sides other than four are not it's rectangle. Anybody is able to find a side that does not have four sides, a shape that does not have four sides, but it's a rectangle? It's impossible, right? So this is something very interesting about deductive reasoning. That is, the contrapositive of the statement must always be true. Let's look at so this is just a brief, very precise summary of the meaning of converse, inverse, and contra positive. Let's look at further example related to this. Now, deductive reasoning is important in the classroom, especially in the mathematics classroom. I think one of the main reason is deductive reasoning enable our students to understand whatever we want to learn with very deep understanding. For example, these are two statements that we can see commonly in any mathematics textbook. And this time, this reasoning involves what we call quantifier, all and some. When the quantifier is different, the conclusion we get from the reasoning may not be the same. Let's look at this. Since all squares are rectangle, therefore, this square must also be a rectangle. Okay, the next one. This is a rectangle. Can we say that it is a square? It may or it may not. And Euler diagram is one diagram that we can use to help us to do this kind of reasoning. Since all squares are rectangle, and therefore we conclude that the square is actually a subset of rectangle. And when we look at the rectangle may be in the region, the square region, or it may be outside the square region. And in this case, it is outside the square region. Therefore, it is not a rectangle. And another example from the secondary school, okay, is involve even number and odd number, some kind of algebra. If we assume that n is an even number, then the number n plus 1 must be an odd number. So with this, we can do certain kind of analysis. If we have two even number, and then the two even number will be n, and we will add the n together, we will get 2n. 2n is a multiple of 2, and all multiples of 2 are even number. So we can conclude here that the sum of two even numbers is also an even number. What about the odd number? The odd number will be n plus 1, so plus n plus 1. With a little bit of manipulation, we will come to the sum as 2 times of n plus 1. It doesn't matter what n plus 1 is, but when it is multiplied by 2, it will be an even number also. So these two conclusions, we can use it to solve this problem. Ali throw 4 darts, one by one, and every dart hit the dartboard, which means every dart will give him a score. If we were to total up these 4 scores, some scores are impossible. So what are the impossible scores?
I think the odds number will not appear.
You won't get odd number.
Yeah.
Why do you say so? This is 4 number. So we are adding 4 number, right? We are adding 4 number, and the sum of 2 number is always even. So adding 4 number is adding 4 odd number is like adding 2 even number. And the sum of 2 even number is even number. So the total score is always an even number. And therefore, odd number score will never be possible. Right. So with this example of deductive reasoning in the primary and secondary school mathematics, I would like to bring our attention to a case in a primary school again. This is the work of a primary school student. Long divisions to divide 30 by 3. Okay. Now looking at this working here, what can we infer from this work? Do you think the student is doing good reasoning? So in order to find out that, I asked this student to explain why did he write the 2-0 down there? And this is the answer. Okay, why? This is the answer we get from the student. Because this is correct. And it actually served no help to us in trying to helping this student to do reasoning. And when I further asked, why is this correct? This is the interesting answer from the student. Because the teacher teach me to do like this. So what do you think about this kind of, this case, this student thinking?
Yeah, I personally think that I'm fine with that long divisions. And because the students are taught to do it this way, and they can get the answers, right? However, I find that there is a hidden kind of issues that exist. If we ask the students about the meaning of this division, most of them are not able to explain. And also there are many teachers do not explain the meaning of these long divisions. And if you look at division, there are actually two forms or two types of division. One is a partitive division, another one is a quotative divisions. So that means to say, if the student cannot explain, the student do not understand these numbers. They just do it, what they call the procedure, following procedure. So as an example, if this is 30 apples, if I want to divide equally by 3 people, so each person will get 10 apples. On the other hand, if this is 30 apples and I want to group the apples in the set of 3, now I get 10 groups. So the first answer is 10 apples and the second answer is 10 groups. They actually are different meaning in different contexts. So students get the answer 10. The answer is perfect, but the meaning can be very different and which one is which. So I think students do this kind of operations without understanding. That is not good.
Yeah, not good. So it looks like this is a case of, although the student get the correct answer, but the student may not understand what does the answer mean. Okay, now this is worrying, I think. This is what we call take for granted learning. Learning which assume that the teacher is always right, and students seldom challenge the teacher thinking because the teacher must be right. Other than that, another issue with this kind of take for granted learning is whatever the teacher teach me, I must follow exactly the teacher taught me. Okay, if the teacher add the 2-0 there, I must also add the 2-0 there. There's no flexibility, there's no reasoning at all. Take for granted learning. The opposite of take for granted learning is what we call reason-based learning. And I think we are going to argue for the importance of reason-based learning in mathematics this afternoon. Looking at this example, this is an example from a secondary school mathematics, solving an equation. Okay. And many students, including some teacher, will solve this equation by this, which is correct, right? They add up 28 plus 5, get 33. And then 33, take away 3 minus 3 is equal to 30. And if we ask any students who did it this way, why do you minus 3? And many students will give us this answer. This is not reasoning. This is just memorizing rules. When you shift side, plus become minus, minus become plus, multiply become divide, divide by become multiply. There is a rule many secondary students relies on. They don't understand why do you have to change sign. So the question now is, if students are not to follow rules, can they use reasoning alone to solve this problem? The answer is definitely yes. Okay, let me show you the example of reasoning given by the student. Okay, one student may give this the reason for getting the answer 30. This student is looking at two sides of the equal sign. One side 3 plus 8. And when he compare 8, when he correspond x with 28, 3 and 5, he noticed that 3 is 2 less than 5. And therefore, x, where does the 2 less than goes to? It must goes to x. And therefore, x must be 2 more than 28. And based on this reasoning, the answer is 30. What do you think?
Yeah. What if I what if I do it another way, based on the idea of the equilibrium in the equations, or whatever items or terms on the left side is the same as the terms on the right side. So on the left there are 3 plus x. So I want the x. So I take away the 3 by subtracting 3 away. So on the right side, I also subtract 3. So I get x equals to 33 minus 3 equals 30. Would that consider be a reasoning?
Oh, yes, definitely. There is another way of reasoning. I think you consider balancing the equation.
Yeah.
You minus 2 from the left side, so you must also minus 2 from the right-hand side so that the equation is still balanced. Okay? I think thank you for sharing that reasoning, because that actually remind us that there are multiple ways to do reasoning. So there's not necessary to limit student thinking or reasoning to just a particular ways. Okay? And then in related to this reason-based learning, many teachers tend to think that reasoning is only suitable for higher grade students. Lower grade students will not be able to do reasoning. Let's look at this example. A similar equation, but of course for primary school, they don't learn equation, so we don't use the term equation. But instead, they learn addition. So we will call this an addition sentence. However, one of the addend is not known. How do we expect a primary school student will be able to use reasoning to find out what number is the teddy bear? This is an example. Okay? The teddy bear plus 3 is 28. That means the teddy bear is 3 more, 28 is 3 more than the teddy bear. So the teddy bear must be 3 less than 28. And therefore, 3 less than 28 is 25. An example of primary school student reasoning.
Yeah.
Okay?
Yeah. So other than that, I think the student should also understand the meaning of the addition sentence, and also the significance of the equal sign, where 3 plus a bear is equals to 28. And again, if we want to strike a balance between two sides, I will subtract 3 away from the left. Similarly, I will have to subtract 3 from the right. So they're going to get the same answer as 25. What do you think?
Yeah, definitely. A good number sense and a good understanding about what it means by adding and what does the addition sentence mean will be very crucial in order to do this reasoning.
Yeah, so for that, I think in order to help children to reason, in the first place, people should be taught to understand the mathematics sentence
Yes.
in a context. And reasoning is only possible if the student understand the meaning of the sentence. And also they are able to make sense of numbers, manipulating the number.
Exactly. So now, since we are talking about the importance of understanding, the questions that we need to ponder now is, what exactly is understanding in mathematics?
Yeah.
So to answer the questions, I think I would like to offer the notions of Richard Scam. Richard Scam identified two types of understanding in mathematics. The first understanding, which he called the instrumental understanding, is knowing how and only knowing how. But a student can do a mathematical procedure, but will not be able to answer why the procedure have to be done in that way. On contradict, the other type of understanding, which Richard Scam termed as relational understanding, is an understanding that is not just knowing how, but is also knowing why it has to be done in a certain way. Allow me to illustrate the meaning with this classical example, divisions of fraction. This is a rule, and everybody learn this rule. Divide, change it to multiply. The divisor 3 over 8, invert it, become 8 over 3, and then do the multiplication and we get 2. How do we explain this rule? Why is it has to be done in this way?
Well, based on my observation in the classroom, most teachers do not bother to explain, and most students can't explain the meaning of their operations. And I think as something common that they practice, 3/4 divided by 3/8, they will just turn the other one, inverse the second factor, 3 over 4 times 8 over 3, without knowing the meaning. So in order to help the students to understand, I think students should be, we should help the student to connect with what they have already learned, especially in division. I give you a simple example. For example, 8 divided by 2. What is that? So we can say that how many 2 are there in 8? So you can divide in a sets of 2, 2, 2, 2. So there are 4. That means there are 4 sets of 2. So similarly, you can relate this to this operation. 3 over 4 divided by 3/8 can also mean that how many 3/8 are there in 3/4? You know, so this is a quantitative divisions. Other than this, you can also look at the inverse relationship between the multiplications and divisions. So divide 3/8 is multiply reciprocal of 3/8, which is multiplied by 8/3. So 3/4 times 8/3 has a reason why we do that, but not just a rule that all you see a division, then you turn it upside down, the second factor, which is again not doing things with understanding.
Oh, you have brought out a very important aspect of relational understanding. Okay, that is making connection. In order to explain the rule, so in whole number revisions, we know that multiply and divisions are inverse. So divide a number is the same as multiply by its reciprocal. Like in this example here, 6 divided by 2 is equal to 6 times half. And therefore, divide by 3 over 8 is the same as times 8 over 3, because 8 over 3 is the reciprocal of 3 over 8. And you also mentioned about quotative division, which is related to repeated subtraction as another meaning of division. And this actually is very important because it helps us to ask the questions of what does it mean. Okay, so how many 2's are in 6 when we do 6 divided by 2? The answer will be there are 3 sets of 6. There are three sets of 2. No, there are 3 sets of
2.
2 in 6. And therefore, the answer of 6 divided by 2 is 3.
Yeah.
This actually helps us. This connection can help us to understand what is the meaning of the 2 in 3 over 4 divided by 3 over 8. The answer is 2. What does that 2 mean? Okay, it simply means one way to make sense of the answer 2 is how many sets of 3 over 8 are there in 3 over 4? And this actually explains the meaning of 2. Now, making connection is very important in learning of mathematics. As explained by Scam, the more connections that a student are able to make with new ideas with the old idea, they mean the better the student will understand the new ideas. So in this sense, we can simply relate Scam instrumental understanding as take for granted learning, but his relational understanding as reason-based understanding. In other words, reason-based understanding is in mathematics is a learning that not only know how to do mathematics, but also able to explain why the mathematics has to be done in that way. So with that, let us look at these ends here. Okay, we have a line of ends marching in single file. Some ends are black, some ends are white. But however, the marching end went into a box, and we couldn't see how many ends are there in the box. And our problem here is we have to find out how many ends are there altogether, although we cannot see the ends in the box. Do you think we can do it?
Yeah, I think we should look for the patterns. I can see some patterns there. First end is black, then 2 white, 3 black, 4 whites, then I don't see them anymore. I have 8 white and 9 black. So it looks like there's a pattern of a black, a white, black, white, black, white with odd, even numbers. I'm just predicting.
So what would be the answer? So there will be 1 plus 2
Plus 3 plus
plus
4
3
until you plus 9.
until plus 9.
Yeah.
Isn't it?
Yeah.
Yeah. Now, I think this example shows us that mathematical reasoning is magical. Magical because it allows us to see beyond our naked eyes. What our naked eyes cannot see, but mathematical reasoning can see it for us. Now, what normally is mathematical reasoning try to see? Pattern. Okay. Once we use reasoning to see a pattern, that will enable us to predict. and we are actually predicting what is the number of n in the box here. Okay, so
Isn't this inductive reasoning when you predict to find the answer?
yes, it is inductive reasoning. Inductive reasoning, where the specific example are used to make general conclusions about certain patterns. So now we come to the question of why is reasoning so crucial and important in learning mathematics? And I think, as we all know, in the year 2000, NCTM proposed the principle and standards for school mathematics. And in these standards, there is one very important standard related to reasoning. What is your opinion on this?
Well, I think NCTM process standard provide a very good guide to mathematics teaching and learning in a classroom. And with that, it helps the ability. Here, they actually promote reasoning, and the ability to reason is very important to make sense of mathematics in different situations, and then using the mathematics ideas or concepts or mathematical facts to explain a lot of situations. And then reasoning also helps us to understand mathematics and enable us to understand mathematics problem.
Yeah, I think I can summarize your idea with this. Okay,
Yeah.
reasoning enables students to gain a deeper understanding, and with the deeper understanding, the students will be able to apply the mathematics they learn in new situation. Not just only that, in the future, when they come across learning a more difficult mathematical idea, their deeper understanding now will be very helpful then. Okay,
Yeah.
so I think this understanding is very clear to us as teacher. However, to students, the younger student, telling them all this may not be able to convince them, because I think they need a more concrete reason. For that, we would like to offer two concrete reasons to convince the student that learning reasoning is very important. Reasoning can help to simplify their work, and reasoning can help to solve the problem. Let's use this example to convince a student that reasoning can help them to simplify the work. These are 5 patterns of color bits arrangement, and we can see that there are certain patterns in this. What do you think about the patterns?
Well, let me try. I actually can see the first one with 1 blue dots and then 3, it's not dot, circle, yeah? And then with first round of circle. Then the second one is also blue circle with 3 and then blue, 3 blue. The third one, a blue in the middle, then 3 white, 3 blue, and 3 white again. So it looks like I can see some forms of patterns that the first blue circle is always there. And if there is a 4th position, then there is 4 rounds of 3 circles. So if it's 5 means I should be able to see 1 plus 5 times 3.
Okay, so we can see that this pattern can actually help us to
Yeah.
find the number of bits for the 10 arrangement or even the 100 arrangement, right?
Yes,
So for the 10 arrangement,
it should be
it should be
1 plus 10 times 3.
31.
Yeah, 31.
The 100 will be 301.
Yeah.
We can, based on this pattern, we can even develop a general formula. And the formula should be 1 plus 3n. I think in mathematics, students learn a lot of formulas, and they are very happy when teacher give them the formula if they can apply it. They find formula can help them simplify a lot of work. And in this case, if students develop the formula themselves, I think the learning will be more meaningful.
Yeah.
Okay. The next example that we can use to convince the students that reasoning can help them to solve problems. 3 coins looks identical, but one coin is fake. The fake coin is slightly lighter. However, if we hold the fake coin, we cannot feel the differences in the weight. Only a balance can do it. Now, if we were to use the balance to find out, so normal case, we need to do 3 times of weighing. If we are lucky, we get it in the first weighing. If we are not so lucky, we need to do this 2 times. And even not lucky, we have to do it 3 times. So the problem for us now is, how can we find out for sure which coin is fake in just 1 time weighing? Okay. This look interesting, right? So if we use reasoning, if we put 2 coins on the weighing pen, 1 coin will be outside, and there are 3 possibilities here. With deduction, if the balanced pen are not balanced, the fake coin must raise up the pen. So we know which coin is the fake. And the second deduction is, if it balanced, the 2 coins in the 2 pens are same, so the fake coin must be outside. A simple example to convince our students that reasoning can help them to simplify works. Now, with that, I would like to conclude our discussion of reason-based learning in mathematics. Now, learning in mathematics has to be sustainable. Now, a lot of teachers complain that what the student learn today, they forget it tomorrow. What they learn it this week, they cannot remember it the next week. So that shouldn't be the case. So with reason-based learning, we are hoping that the learning of mathematics can sustain for a long time. Okay, because children who are mathematically literate and proficient are the result of reason-based learning. Being literate in mathematics means students are able to understand the mathematics they learn and also apply the mathematics they learn. And being mathematically proficient means it refers to the procedure of doing mathematics. So students will be able to carry out those procedures more efficiently. And other than these two, the other 2 aspects that we can hope from reason-based learning are to boost student confidence. As students become more confident, the learning will be more sustainable. And other than that, they can be smarter students. Smarter students here refer to students who can learn in a more flexible way, not just confined to one way. Okay, with that, we would like to sum up our discussions on mathematical reasoning with the importance of the question why. To reason is to ask and answer the questions why. That is, we need to provide opportunity to encourage the student to ask and answer the questions why by themselves and also for themselves. With that, the final question that we need to ask is, why is asking why important in the teaching of learning of mathematics?
Well, in my opinion, every learning mathematics should be supported by a reason. And this leads to a further exploration of more related maths content or related knowledge and for solving the problems. And then this also gradually lead to a progression of a higher level of learning by the students and doing it themselves. So, in my opinion, I feel that children should be trained how to reason, to face challenges of the future learning. And teachers are very concerned about reasoning because the reasoning takes, teaching through reasoning takes a long time. And then we always say, oh, we do not have the time. So giving them the answer, helping them to get answer is the easiest way. So in regards to that, 2 or 3 days ago, we heard the new announcement that the MOE Malaysia just announced the abolishment of our public exam, UPSR for year 6 and PMR for grade 9. So without the burdens of a public exam, I feel that maybe our mathematics instruction should be realigned to emphasize more reasoning and also to promote mathematical thinking, which is also the higher order thinking that we always advocate, you know. So maybe this is an opportunity for us to change our mode of teaching.
Oh,
Yeah, Mr. Gan.
I think that is an excellent piece of summary for our discussion today. And thank you everybody for being here with us. We shall continue our discussion on the how aspect of reason-based learning, how to promote reasoning through reason-based learning in session 2, which is on the 6th of May.
Yeah. So before we sign off, we promise that we'll take 1 or 2 questions. And there's a question here. Our audience asks, is reasoning the same with critical thinking skills? Is reasoning the same as critical thinking skills?
Oh, reasoning, critical thinking. It's all about thinking. I would say there are some common features in that. They are all about thinking,
Yeah.
but there are also differences. Even critical thinking itself, there are different meaning about it. So I would just say that reasoning is involved in a lot of critical thinking, and then critical thinking will a lot of time will assist us in doing our reasoning.
Yeah.
Okay.
Thank you. And I hope our listener got what you asked for. And perhaps as another question, when is the appropriate time or stage to promote reasoning?
Appropriate time to promote reasoning.
Yes.
Well, I will say anytime. But of course, as a teacher, we only deal with our students when they come to school. I will say from the first day our students come to the school, that is the time we can start doing reasoning with them. I think that the whole issue is not about when to start asking our students to do reasoning. It is more a questions on what is the appropriate reasoning task that we can design that suit the level of our student. If our student is at primary 1, grade 1 level, then it will be a challenge for us to design a reasoning task that is suitable for them, a reasoning task that they could understand, a reasoning task that they can make sense of and then struggle to solve it. Of course, as teacher, it is very important for us to stand by them to provide any support they need. And with our support and with appropriate tasks, I think students can start learning about reasoning in mathematics at any age.
Yeah. Thank you, Mr. Gan. There's another question. I'm not sure whether you want to answer today or we leave it to the next session. Is there any set of procedures in promoting reasoning?
I would answer this today. I would say there is no one definite set of procedure. There are multiple ways and multiple procedure. Okay, so on which way to choose, I think it's all up to us. And on next session, session 2, perhaps we will share one of the way that we choose to share with you.
All right.
Okay.
Thank you very much for all this. And we would like to invite all our audience to turn on your camera or your video so that we can see you, and we really hope to capture a picture together. Yeah, Diana, can you help us? Okay, everybody on your camera. Dr. Min, can you be seen? You're in. All right. Yeah, give us a sweet smile. Today is Friday. Happy day. Yeah. Okay. Anyone?
Mr. Henry, can you on your video?
I have a problem to access the evaluation link. Oh, okay, okay. Have you done, Diana? Yeah. Okay. Okay, another time on your camera. Okay.
1, 2, 3.
Thank you. Then next one.
Second screen. 1, 2, 3.
Any more?
Third screen.
Third screen now. And the last one.
Okay.
All right. Thank you very much, Diana, for helping us to take the photo. I have posted the link to get some feedback from you. Before I close this sessions, I will draw their attention to the chat to access the link for feedback form. Those who attend both the sessions accompanied with the feedback form for the 2 sessions will receive a certificate of participation from Rexham. So don't forget to join us on the 6th of May, 3 to 4 p.m. again. And I hope you enjoy our discussions. And lastly, I would like to say thank you to each and everyone who participate in this discourse. I hope you pick up something worthwhile and take back to your classroom and share it with your students. Last but not least, I would also like to say thank you once more to Mr. Gan for being the anchor of this session. Thank you, Mr. Gan.
Same to you, Miss Day.
Yeah, and thank you very much, everybody. So long. Stay safe till we meet again on the 6th. Bye-bye.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye bye.
Bye-bye.
Thank you.
Bye.
Thank you.
Bye-bye.
Bye-bye, everyone.
Bye-bye.
Bye.
Bye-bye.